Before we begin today's configuration, let's go over what we'll be exploring. In this episode, we're focusing on the two technologies that quietly shape the way a modern Layer 3 switch operates: switch virtual interfaces and hot standby router protocol. We'll see how SVIs let a switch take on the gateway role for each VLAN, and then we'll look at how HSRP keeps that gateway available even if a switch fails. Together, they give the network a solid foundation for high availability. As we move into the configuration, let's take a moment to understand what an SVI actually is. You can think of a VLAN as a small neighborhood inside your network. All the devices in that VLAN live in the same area, but they still need a single, consistent place to send traffic when they want to reach anything outside their own subnet. That place is the gateway, and an SVI provides that gateway. It's a virtual Layer 3 interface tied to the VLAN itself, not to a physical port. When you assign an IP address to an SVI, you're telling the switch, you are the gateway for this VLAN. From that point forward, the switch can route traffic between VLANs internally, without relying on an external router. It's a simple concept, but it's what allows a modern Layer 3 switch to handle inter-VLAN communication efficiently and cleanly. Now that we understand what an SVI does, acting as the gateway for a VLAN, we can talk about how we can keep that gateway available even if something goes wrong. And that's where HSRP comes in. HSRP, or Hot Standby Router Protocol, is a redundancy mechanism that lets two switches share the responsibility of being the gateway. Instead of every device in the VLAN pointing to a single switch's IP address, they point to a virtual IP address, an address that both switches agree to protect. Here's how it works. One switch becomes the active gateway, handling all the traffic. The other switch sits in standby, quietly watching. If the active switch fails, the standby switch takes over the virtual IP and becomes the new gateway. To the devices in the VLAN, nothing changes. Their gateway stays up and traffic keeps flowing. So when you put it all together, the SVI gives the VLAN its gateway, and HSRP makes sure that gateway never disappears. It's a simple partnership, but it's what turns a basic Layer 3 design into a highly available one. In today's lab, we'll build a gateway structure for our VLANs by creating SVIs and designing them around HSRP to provide gateway redundancy. Each SVI will act as the VLAN's gateway, and HSRP will let two switches share the role through a virtual IP address. We'll configure the SVIs on our Layer 3 switches, apply HSRP to them, and then demonstrate redundancy by taking down one of the participating SVIs to watch the standby switch take over the virtual gateway. After verifying the failover, we'll configure management SVIs on our Layer 2 switches for VLAN 20 and set their default gateways to HSRP's virtual IP so they also benefit from the redundant gateway design. Now that we've finished configuring HSRP, we're going to take a moment to demonstrate how the failover process works. To do that, we'll bring down the active router's VLAN 10 SVI on branch 1 and watch how the standby switch immediately steps in, takes over the virtual IP, and becomes the new active gateway. This gives us a clear, real-time look at the redundancy HSRP provides and how it keeps the VLAN's gateway available even during a failure.